Hello my dear students, welcome to LBD Tuition Center. In today's class, we're gonna study and going to cover a very vital and important topic for GCSE combined and triple science students for AQA chemistry. So our today's topic will be on chemical changes. So here we go. Let's start with that. In this class, we're going to cover the following topics: acids and bases, their basic difference, strong and weak acids and bases, reaction of acids, acids, bases and pH, reactivity series, titration, extraction of metals, electrolysis, components of electrolysis. We're going to study the process of electrolysis and the prediction of the products in this process. And at the very last, we're going to discuss some questions on these following topics. So let's start with acids and alkalis. At the very first, we're going to discuss about the properties and the physical characteristics of acids and bases. Acids are sour in taste, whereas bases are bitter. Acids are corrosive to metals, whereas bases are corrosive to organic materials. Acids reacts with bases to form a salt and water, whereas bases reacts with acid to form a salt and water. On pH scale, acids have a pH less than 7, whereas that of bases is greater than 7. Students, for your information, I will just mention this. 7 is not included in both acids and bases, because 7 is the pH value of neutral substances like water. For litmus paper, acids are red, they turns red, and bases turns litmus paper blue. For physical test, bases appear slippery. In the diagram, you can see we have taken HCl, NaOH and NaCl, where HCl is a acid, HCl is an acid, NaOH is a base, and NaCl is a salt. Now we have dropped all these three things over in a beaker with water. If we're gonna make a solution out of it, we will see all the substances got dissociated into its ionic form. Ions. So basically, ions are substances in which the compound has broken. Ions do have charge, so they can be easily used for and easily be associated with some processes like electrolysis. Let's commence to the next topic. Reaction of acids. When an acid reacts with a base, the product that is formed is a salt and water. For example, if we have taken a strong acid, that is HCl, with NaOH, that is a base, the product that will be formed will be a salt, NaCl, and water. Water is definitely formed out of the reaction between an acid with a base. This reaction is called as neutralization reaction. As HCl gonna increase in its pH and NaOH is gonna decrease in his pH, bringing it to a pH that is of NaCl of 7 and that of water as well. So the products that are formed in this reaction are NaCl and H2O, which have both pH of 7. So the process is called as a neutralization reaction. So as I have already explained about neutralization, in this diagram it's very clear that whenever a sodium hydroxide or a base is added to an acid of a lower pH, they're gonna neutralize to a solution that has a pH value of 7. As sodium hydroxide has the maximum value of pH and hydrochloric acid do have the minimum value of the pH, they both are strong acid and a base. So the product are strong bases. So here is a list of some strong acids with some strong bases, with some weak acids and weak bases. Most of the time, the organic acids are weak acids. Some of the well-known strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Some of the well-known strong bases are sodium hydroxide, barium hydroxide, and potassium hydroxide. These following strong acids and bases are mostly used up in experiments in labs. All the organic acids are listed in weak acids, such as carbonic acid, formic acid, acetic acid. You might have heard these names over in fruits and vegetables. Weak bases. So one of the very common weak base is ammonia and that of sodium bicarbonate. Now what is the difference between a strong and a weak acid and a weak acid and weak base? Strong acids are completely getting dissociated into ions when dropped into an aqueous solution. Say for example, if we will talk about HCl in aqueous solution, it will get completely dissociated into H plus ion and chlorine ion. And we know that acids are proton donors, that is H plus donors. So they're gonna dissociate into maximum number of H plus ions. Whereas in weak acids such as ethanoic acid or acetic acid, it doesn't completely dissociate into the maximum number of H plus ion that this compound do have. Like it do have H3, like 3 hydrogen here and 1 hydrogen at the very last. So it only gives 1 hydrogen ion out of this instead of 4 hydrogens. So this is not completely dissociated into its ionic form. So not many number of H plus ion can be extracted from this. So this is an weak acid. In case of weak base like NaOH, this also completely dissociated into Na plus and OH minus. Because of this OH minus or hydroxyl ion present over here, it gonna attract or will make a compound with H plus ion. So that's why they are called as proton acceptors. So bases are proton acceptors. Same with this is again not getting dissociated completely into OH minus, that is going to neutralize the H plus ion in the solution. So this is a weak base as well. So this is all about titration. Let's start with another topic, that is reactivity series and extraction of metals. So this is very important to note down that in reactivity series we have to go through this chart. Over in the chart you can see we have all the alkali metals that is present in the extreme left of the periodic table at the top of carbon. In between that we have got all the transition metals, and After that, we have got hydrogen and followed by some very, very unreactive or less reactive metals. So how are you gonna remember these things? So you can make a mnemonics out of it, or you can just remember this thing that all the alkali metals do have more reactivity than that of carbon. Now because of that, these metals or these elements are extracted by the process of electrolysis that we're going to discuss after this. Electrolysis can also be used to purify copper. So this is one exception. Now the one that is present in the middle, that is the transition metals, most of it, do have a less reactivity than carbon. So these metals are less reactive than carbon, so they can be extracted from their ores by reduction. So what are ores? Ores are basically impure form of the elements. Now the electrodes that we use in this for the reduction process are most of the time carbon or graphite, coke or charcoal. So we make electrodes out of this tree in electrolysis process as well to extract these metals from their metallic salts. And the least reactive metals that we always use for making ornaments and all that, basically they have very less reactivity than that of hydrogen. So these are also called native. They can occur in their native and do not need to be extracted. So they doesn't need to be extracted. They are already in their pure form. But whatever impurities they do have, they can be easily purified by some other processes that we will discuss afterwards in higher classes. So let's talk about electrolysis. So this is the process by which with electricity we are lysing, that is we are breaking down the impure form or impure part of the compound from that of the metal that we want to extract. In electrolysis, the components that we need to remember is electrodes. Remember, the positive one is always anode. So the alphabetical order starts with A. So A is always positive. Just remember it in that way. So anode is positive and the cathode is negative. So these are the two electrodes that we always need to maintain a flow of electrons through the battery. So battery is the source of the electrons, and the electrodes are maintaining the flow of electrons because of a positive and negative charge. Next, what we need to do is we need to have an electrolyte solution. Always remember, we need to have a solution, or even if we are taking a metal, it has to be in its molten form, as electricity can always flow through watery or solution, not through a solid substance. Let's say if it would have been a crystallized thing or crystallized material over in the electrolyte, electricity would not have been passed through. Even if electricity can pass, the ions wouldn't have moved from one terminal to another to get purified or get extracted. Now, cathode is going to attract the positive charge, that is called as cation, and the anode is going to attract the anions that are negatively in charge. Let's talk about the application of electrolysis. Number one is electroplating. Plating of a thin layer of a metal on another metal to prevent corrosion or improve appearance is called electroplating. Number two is extraction of reactive metals such as sodium or aluminium from their ores. Number three is industrial production, that is industrial production of some bases, chlorine for bleach and hydrogen gas for different other purposes. Now, types of electrolysis. Thank you. Now, electrolytes can be either molten or solution. The molten electrolytes will be PO, an ionic compound, a liquid form, or molten electrolysis, or it's a solution electrolysis where we have taken an impure form, a mixture of ionic compounds. By this process, we're gonna extract pure form of metals from its impure ores. Now, types of electrodes. The electrode that we use might be inert electrodes and active electrodes. Active electrodes are actually participate in electrolysis while providing electrical current, usually made of the metal that corresponds to metallic ions like zinc, copper, aluminium, chromium, and nickel. Inert electrodes do not actually participate in electrolysis. So they are not participating in electrolysis, so they are only absorbing and giving off electrons. They are not participating over in the donation of ions or ionic elements. So inert electrodes we actually uses for transition metals, for the extraction of transition metals, and the electrodes that we use over here are basically active electrodes in most of the extraction processes. So for electrolysis, the mnemonics that you need to remember is anox care. This is personally I have made. You can just remember this thing like this. So anode has oxidation. Oxidation occurs in anode and reduction occurs in cathode. So you can just remember it like anox care. So you're just taking care of an ox. Is it like that? Okay. So basically, anode undergoes oxidation and cathode undergoes reduction. And as we all know, reduction means gaining of electrons and oxidation means loss of electron. So always remember, whatever element is present over in the anode terminal is going to lose electron, and whatever ion will move towards the cathode terminal is going to gain electron. So here is the difference between anode and cathode. So products formed in cathode and anode in different electrolytes. Cathode will attract the positively charged ions, that is cations. Anode will attract the negatively charged ions, that is anions. Let's now talk about some salts. Now let's talk about three different electrolytes. Number 1, copper sulfate. Number 2, magnesium chloride. Number 3, magnesium sulfate. So we have taken three different electrolytes. In the first one, we have copper and we have sulfate. So we have no halide element over in this compound. In the second one, we have taken magnesium chloride, where we have taken an halide compound. And in the third one, we have taken magnesium sulfate, where magnesium is having a very high reactivity. So let's start with copper sulfate. Now, as I have already discussed with all of you that we have to remember this mnemonics, that is anox, care. In this one, we have anode undergoing oxidation and cathode undergoing reduction. Just recall what we have learned. Anode is the positively charged electrode. That means it's gonna attract the negatively charged ions. Let's discuss about which ions is going to migrate towards the cathode and which ions is going to migrate towards anode, their half equation and the prediction of the products that will be formed. Now for copper sulfate, it's not copper sulfate is there only in the electrolyte. With copper sulfate we have water. So the ions that will be formed will be copper and sulfate from copper sulfate, and from water we have H plus and OH minus. If we will see, for positive ions we have got copper and we have got hydrogen ion. For negative ions we have got SO42 minus and hydroxyl ion. Now we will carry out what will happen at the cathode end and what will be the product over in the anode. Now cathode, according to this mnemonics that we have to remember for sure, that is cathode will undergo reduction, that is gaining of electrons. Now cathode is itself negative, so it's gonna attract the positive ions. So we have two options, copper and hydrogen. So between these two we have to compare according to their reactivity. Remember, I have shown the reactivity series where copper is less reactive than that of hydrogen. So the element that will be formed at the cathode end will be the less reactive one. We have to always keep it in mind, or the metal that will be extracted in the cathode electrode will be the less reactive one. So over here between copper and hydrogen, the less reactive one is copper. So the half equation for this will be copper, that is dissociated into its ionic form, is going to, as we have that copper to have a charge of 2 plus, is gonna take up 2 electrons from the solution and becomes a copper atom. Here copper is in ionic form, is going to gain 2 electrons and forms a copper atom. Now for this we have been left out hydrogen ion over in the solution. So hydrogen ion has not been taken up by any of the electrode. Let's now move on to anode. So at anode end what we have to see, as we know anode is going to attract the ions that are negative. So we have two options here. One is SO4, that is sulfide ion, and that of OH minus, that is hydroxyl ion. In this too, we have to see which one is a halide compound or element. We can see here none of them are halogens. So definitely the product that will be formed will be an oxygen gas and water. So make sure, remember this, when there is no halogen over in the compound, the product that will be formed at the anode end will be definitely oxygen and water. So let's write the half equation of what's going on in the anode end. So as we know, anode is undergoing oxidation reaction. So the ion or the element we have there is supposed to lose electron. So we have OH minus, that gonna lose electron, plus the product that I'm sure about, that is your oxygen and water. Now in this one we have 2 oxygen and 1 air. So we have got 3 oxygen produced over in the product. So we have to balance it. So we're gonna write 4 air. So with respect to that, 4 electrons will be taken off from there and 2 oxygen atoms, 1 oxygen atom will be formed with 2 water molecules. So this is the balanced equation that will be formed out of at the anode end. So if we will combine these 2 half equations, so the product that will be formed will be copper ion plus 4OH minus plus 2 electrons gives you 4 electrons plus O2 plus we can just make it a bit better. So the product that will be formed will be copper plus 2 electrons plus 2 4OH minus will give you copper plus oxygen, that is a gas, plus 2H2O with 4 electrons. You can just cancel out the ions in both the end and can balance the equation. So this is the reaction that will be formed and the product that will be formed when we will take copper sulfate as an electrolyte. So we can see here copper is used up and hydroxyl ion has been used up. So whatever will remain over in the electrolyte will be SO4 and H+. So these are the 2 things that will combine together and will be extracted out from the bottom of the electrolyte solution. Let's talk about the second ion, that is the second compound, that is magnesium chloride. So in this compound, so what we need to do, we have to just rub out whatever we wrote. So we have got here. So we can just move on to the next compound, that is magnesium chloride, and we will similarly make same half equations out of it, and okay. So let's start with magnesium chloride. Similar to copper sulfate, we first need to write about the ions that we're gonna get over in the solution. So from magnesium we will get Mg2 plus and we will get chlorine, and from water we will gonna get H plus and OH minus. So in this one, if we will see, so for cathode we're gonna get 2 ions, magnesium and hydrogen. Now from the reactivity series, again this is clear that magnesium is more reactive than hydrogen. So in this case we have got hydrogen that is less reactive. Always we need to remember that cathode is going to revolve a product that is less reactive. So in cathode end, the product that will be formed in this case is hydrogen, because magnesium is more reactive than hydrogen. So here we have got H plus ion that is going to gain one electron and becomes hydrogen gas. So we have taken 2 atoms of hydrogen here. So we have to balance it by putting 2 over at the front of it, and then it will be balanced. So same electron we have to take for this as well. So 2 electrons taken up by 2 ions of hydrogen will form one hydrogen gas molecule. Now same thing we're gonna do for anode as well. So for anode end we have got chlorine and hydroxyl ion. So for chlorine and hydroxyl ion, if you will see, so we have got halide ion here. So as halide ion is already present, so definitely you're gonna get a product of halide ion, that is halogen gas. So here we will get Cl minus has to lose 1 electron and become Cl2, that is chloride gas. So 2 electron will be taken off from this and a chlorine gas will be formed. So if you will combine these 2 reactions, you will get 2H plus 2Cl minus plus 2 electrons will give you hydrogen gas and a chlorine gas plus 2 electrons over here as well. So this 2 electrons is going to get up, and we are only left out with H plus 2Cl minus gives you H2 and Cl2. So how you gonna predict that which compound is obtained at the bottom of the container? So we have used up hydrogen from here and chlorine from here. So the thing that is left out is magnesium and OH. So the compound that is formed over here will be magnesium hydroxide. As this is having a valency of 2 plus, so we will have to make the compound as MgOH2. So the compound that will be obtained at the bottom of the container will be magnesium hydroxide. Let's start with the next one. So you are now quite clear about how we gonna form compounds out of it. So next element or compound that we gonna discuss about as an electrolyte, and whatever will be the possible products formed out of it will be magnesium sulfate. So in this one again, magnesium sulfate is a solution. So we have got magnesium sulfate with water. So the ions that will be formed from here will be Mg2 plus and SO4 2 minus, and for water it will be H plus and OH minus. Right now in this one, same for cathode and anode we're gonna discuss. Now for cathode end, we know that it's the positively charged elements that's going to gets attracted by cathode end. So we have got 2 options here, magnesium and hydrogen. Now from cathode mnemonics, we know cathode is undergoing reduction, so it will definitely gain electrons. So we have 2 options here, magnesium and hydrogen ion. So who is going to gain electron here? The less reactive metal or the less reactive element, right? So here is hydrogen less reactive than magnesium. You can just go over the reactivity series once again and just check it over there. All the alkali metals are more reactive than hydrogen and carbon too. So we are going to have hydrogen here as less reactive metal or the element. So here also the production of hydrogen gas will take place. So hydrogen as we have already done it, I'm just balancing it at the very first. So it's 2H plus going to get 2 electrons and form hydrogen gas molecule. So this is the product that we will gain over in the cathode end, and over at the anode it's going to attract the negatively charged ions. So we have two options here, SO4 and OH minus. Now here there is no halogen, so the product will be definitely oxygen gas and water. So the product we all know is oxygen gas and water. Just I'm writing it straight away, the product. So where from it's forming? It's forming from OH minus. So 4 molecules of OH minus we're gonna take, that will take away 4 electrons out of it. So we will get 1 molecule of oxygen and 2 molecules of water. So that is the balanced equation that we will get out of it. So here is all about the electrolysis. So here is all about electrolysis. Then we can just move to electrolysis, the components of electrolysis, applications of electrolysis, types of electrolysis,